And now we're going to be talking about something we call Pythagorean theorem. Okay, so let me explain what Pythagorean theorem is. Let me just write here. This happens only when we have a right triangle. So let me draw a right triangle. A right triangle is basically a triangle where one of my corners is 90 degrees. So this happens on the right triangle. I'm going to call my sides A, B, and C. Okay. The biggest side, the one that is farthest away from my 90 degrees, I'm going to call that C. That's usually called the hypotenuse. But for right now, I'm going to call it C, right? Like I said, I'm going to label my sides A, B, or C. But that one is C. The biggest side of the three is going to be the hypotenuse, which I'm going to label C. The other two, basically the two sides that meet at the 90-degree corner, we should call those legs, okay? The two that meet at the 90-degree corner, we call those legs. I'm going to call one of them A, the other one B. It doesn't matter which one's which. So let me call this A, and let me call this B. Again, it doesn't matter which one is which. The important thing is the hypotenuse, the biggest side is C. Now, Pythagorean theorem is the way we're going to add sides. And the formula that was created, we're going to go A squared plus B squared is going to equal to C squared. So, matter of fact, people in construction, people that put tiles or make floors, people working construction, there's this rule that for them to know that they have a 90-degree corner, they call it a perfect corner, or a nice corner, or for them to know they're going straight in construction, they have a rule. You can ask people in construction, they call it the 3-4-5 rule. Ask them, and what they measured is that one side has to equal to 3, right? 3 feet, 3 meters, whatever they're doing. One side has to equal to 3, the other one has to equal to 4, the other one has to equal to 5. In reality, 3 squared plus 4 squared is equal to 5 squared, right? They're using this rule called Pythagorean theorem. They don't know. Most of them, they don't know. They just call it the 3-4-5 rule. If you know people in construction, ask them, what's the 3-4-5 rule? And they will explain it. That's really what we call Pythagorean theorem, okay? So it's A squared plus B squared equals C squared. Now, let's take a look. Like I said, that happens only in the 90-degree corner. So here, find the missing side of each triangle. Leave your answers in simplest radical form. We learned how to simplify radicals, so actually we're going to use this. So the way I'm going to label my sides, it's the side that is farthest away from the 90-degree corner, I'm going to call that C. And the other ones I'm going to call A and B, okay? Remember, the one farthest away from the 90-degree corner, the biggest side is my C, the hypotenuse. I know the formula is A squared plus B squared is equal to C squared, right? That's the formula we're going to use for Pythagorean theorem. So what I'm going to do, here in my work, let me square everything. 12 times 12 is 144, right? X times X, it's going to be X squared. I'm squaring everything. Now, interesting part here, radical 82 times radical 82. When you squared a radical, right? 82 times 82 is going to give me a big number, right? Let me just write here as a symbol. But then if I was to ask you, think of a number that multiplied by itself equals that number. Wouldn't you say 82 times 82? Because that's basically how we got there. One nice thing, when you squared a radical, radical 2 times radical 82 times radical 82, I'm just going to get 82. Square roots and squares cancel each other out. So square root of 82 times square root of 82, it's 82. Okay, so I squared everything. So according to the formula, I'm going to write x squared plus 82 is equal to 144, right? A squared plus B squared equals C squared. I don't have radicals right now. I might deal with them in my answer, but right now I don't have any. Okay, I'm trying to get the x squared by itself. So this plus 82, let me move it over as a minus 82. So that gives me that x squared is equal to 62. I'm not asking you to solve for x squared. I'm actually solving for x. So, how can I get rid of a square? I said earlier, squared and square roots cancel each other out. So x is going to be the square root of 62. Because technically, do the square root of each. So x equals the square root of 62. Now simplify your radical if possible, because your instruction said leave your answers in simplest radical form. Can you split 62 as two numbers that multiply equals 62? One of them is a perfect square. My mind, I think of 2 times 31. Neither the 2 nor the 31 are perfect squares. No, nothing I can do. So my answer is radical 62. Nothing I cannot simplify. The way you're going to type this, you're going to go rad 62. You're going to use parentheses, and you're going to put the 62 inside the parentheses because the 62 is inside the radical. So radical 62. All right, let's take a look at question number 10. I'm going to square everything, right? To begin with, let me label my sides. This is C, is the one farthest away from the 90-degree corner. And I'm going to call this A, and I'm going to call this B. Now let me square everything. 7 times 7 is 49. X times X, X squared. 5 times 5, 25. I multiplied everything by itself. And I'm going to have that 25 plus X squared is equal to 49. I want to have the X squared by itself, so let me subtract the 25. Right, notice I switched the sign. X squared is equal to 24. So that means that X is the square root of 24. All right, now simplify the square root of 24 if possible. I'm going to break this into two radicals. I'm going to think of two numbers that multiplied are equal to 24, but one of them is a perfect square. So first I think 2 times 12, and no, that one doesn't work because the 2 and the 12 are not perfect squared. 3 times 8, no, that one doesn't work. But 4 times 6 does work because the 4 is a perfect square, right? Square root of 4 is 2. Square root of 6, can I do better? No. So my answer would be, if I was to write this, my answer is 2 radical 6. If I was to do this on paper, it is 2 radical 6. The way I want you to type this is going to be 2 rad 6. So 2 radical 6. All right, let's take a look at number 11. My hypotenuse is my C, right? The biggest side is C. The other side are A and B. Now I gotta think of my multiplications. What's 16 times 16? 256. So when I squared everything, this is 256. 11 times 11 is 121. X times X is X squared. So I'm going to write this as 121 plus X squared equals 256. The 121, let me move it over as a minus 121. Now 256 minus 121 is 135. So X is equal to the square root of 135. Gotta remember perfect squares. 4. Can I go 4 times something? No. Then 9. Oh, I can go 9 times 15. 9 times 15. Okay, because the square root of 9 is 3. Square root of 15, nothing I can do. Right? I cannot simplify. So my answer, if I was to write this, is just 3 radical 15. The way I'm going to type this is going to be 3 rad 15th. Don't forget the parentheses, no spaces in between altogether. Okay, let's take a look. I'm gonna say C is my hypotenuse, and I'm gonna call this side A, I'm gonna call this side B. Let me square everything. This is x squared, this is 36. I'm gonna do the easy stuff first. Now, square root of 26. When you square the radical, you just get the number inside. Oh, so that was even easier. So I'm gonna have 26 plus 36 equals x squared. Now, these numbers are together, right? 26 plus 36, that's 62. So I have that 62 is equal to x squared. So that means that the square root of 62 is equal to x. Can I simplify this? Can I break it into two radicals? Nope, I can't. So if I was to write this, it's radical 62, right? The square root of 62. The way you're gonna type this, you're gonna go rad for radical. Notice I went lowercase, inside parentheses 62. Radical 62. Now, one thing you guys are gonna deal with in your homework is that one of your triangles, let's come up with a triangle here. When you're squaring a whole number, it's easy, right? When you're squaring a radical, let's just have a radical 3, it's easy. Because when you squared 10, right? 10 squared is 100. When you square a radical, you just get the number on the inside. Now in your homework, you're gonna have a mix. What I mean with a mix is like, what if I have like 4 radical 3? So what if I have a whole number and I have a radical? If it was just the 4, if it was just the whole number, 4 squared, I know is 16. If it was just the radical 3 squared, I know is just 3. Now, because it's both, multiply those. 16 times 3 is 48. So again, let me just say this. When you just have a whole number, just multiply by itself. When you have a radical, it's easy, right? When you square it, you get rid of the radical. Now, when you have a whole number and a radical, square the whole number first, square the radical, and then combine them. Okay? Should be good now.